Hello, it's me from chapter 1. Here we are going to learn how to do Kruskal's algorithm with this example problem. The reference to this example problem is in the references list, a YouTube video. So, to start, in the Kruskal's algorithm, you have to start with the shortest edge. The key to Kruskal's algorithm is that you're not supposed to form any cycles, wherein you connected to an edge that that is already connected in your tree. So we can see that there's a 1 here. If there was another one, or another one to choose from, let's say if this 8 was 1 for instance, just for example, if that was the case, we can choose between the top one or the bottom one. It doesn't matter. Anyway, so let's start with 1, because that's the shortest. After this, we have to choose the shortest edge. Again, we have 2 and 2. Since none of them form cycles, we can choose any. And I want to choose this one. The shortest after this 2 is then this 2. So I'm going to choose this one as well. Now, the next shortest distance here in this graph would be 4. There are 2 4s, this one and this one. None of them form cycles, so we can choose any. Say I want to choose this one, this 4, which connects W to T. The shortest one after that is R to S. So I'll choose R to S. The next shortest distance in this graph would actually be X to Y. But if we take a look at X to Y, it forms a circuit. See? It connects Y to X, which is already on our tree, so we cannot use that. I will color this with red so that we know that we cannot use that. Now, after 6 is 7, that's the next shortest. We have a choice between YZ and TU. If we take a look at YZ, we can see that it's already connecting to our tree, so we cannot use this one either. I will color this as red. TU, on the other hand, does not connect to our tree and does not form a cycle, so we will highlight this as our next part of our minimal spanning tree. After 7 is 8. 8 is the next shortest distance. Now look here, this is an interesting one. See this 8 of RZ, I'll use red first. 8 of RZ and 8 of ST. We can choose any of these. The thing is, when we choose one, for example, let's say we choose RZ, I'll just use white. Let's say we do choose RZ. We can no longer choose ST because it will already form a circuit. See, it will already form a circuit. And the opposite is also true. If we choose ST instead, this one, choosing RZ would instead form a circuit. That's also not what we want. For my problem, or for least for my solution, I will choose ST. Next, After selecting that, the next lowest shortest distance would be 9. But first, I'm going to highlight this with red so we know not to use it. So we know that this forms a cycle. I will actually label it here, that red forms cycle. Now, so we have the choices between 9, 10, and 14. The shortest distance here would be 9, UV, this one. So we'll choose this. The next shortest would be 10, WV. However, that would form a circle. So I will highlight this as red. This forms a circle. Of course, UW is the longest distance, and it will also form a circle. I'll just label it red. So the green is our minimal spanning tree. I'll just write it down. Is our minimal spanning tree.